2022 JEE aspirants, and if you are preparing for any other exam in the and you are in 12th standard and you're going to write the examination next year, guys, you're all welcome here. This is the second session of the Pathfinder series and also the second session of the chapter Electrostatics. And welcome aboard with me, Shreyas, your master teacher for physics at Vedantu, going live. For those of you who do not know me, I am in Vedantu since a long time, and before that I have been in offline coaching industry for almost a decade. And when I was teaching in offline industries, I have produced really amazing ranks, and many of my students are doing extremely well in IITs, NITs and BITs. And I really hope, because that's my dream, guys, to make sure that every student learns, they enjoy. And I love physics. In fact, when I wrote my JEE, I almost scored full marks in physics. And I want everyone to have that hope. I want to build that trust. I want you guys to be confident about the exam. I want you to learn the subject. I want you to enjoy the subject. So that's why I'm here, to spread the knowledge, to spread the joy of learning to all the students across the country and even across our borders. So welcome aboard. Hi Yashwant, Yalini, Rajni, Priyanka, Munabai, Manki, Swati, Ankit with all the hearts again. Hello. Munabai is also here. Shreyas Kapri. All right, loving the thumbnail, Shreyas. Glad you liked it. Hi Samita, welcome. Yes, your Capto is here. Bhargav. Hello Neha, nice to see you all again. Hi Srinu, Kartika. Hello Amu. Hi Kartik Reddy. Welcome. Hello Manoj. Good evening. Hi Srinu. Hello Ria. Hello Nitish. Welcome aboard. And guys, a lot of updates coming up. So if you want to know more, understand, you need to also follow me on my Instagram handle. Yes, please do that, Shreyas_Vedantu. And do not forget to smash the like button to show us your love, support. And also do not forget to subscribe for free if you want to be a V enthusiast. Hello Surya, welcome. Hello TRI. And remember guys, the V.O.T.E, which is the Vedantu Online Talent Examination, is still being conducted. There are 4 times you can vote. Yes, underage kids can vote, and the next vote date is 11th of April and then 18th of April. And through this, you're going to get lots of scholarship from a pool of 500 crore rupees. Also lots of prizes to be won, like telescopes, power banks, mobile phones, Xbox, also the chance to go to NASA or become the CEO of Vedantu. So do not forget to check out the link which is there in the description box below. No problem, Surya. The advantage of YouTube is you can always replay and you can watch the recorded session. But trust me on one thing, there is no fun watching it recorded. Understand, it's always fun to watch all the lectures live. So if at all you miss, it's okay. You can watch the recorded series, but it's always fun to watch the live ones. So this is the Pathfinder series schedule as of now. We are completing electrostatics and we are ending with a Menti quiz. Let's see who's the Menti quiz winner going to be. And lots of sessions, detailed session for forces, potential energy, dipoles, field lines, equipotential surfaces, everything in detail. And this is your Zero to Hero series for all the current 12th standard or the students who are going to write the examination this year, 2021 aspirants. All right, be it mains or advanced. So lots of series lined up, lots of lectures, all the topics of 11th and 12th covered in Zero to Hero. There is a playlist which has been created separately. Please check it out. And also advanced series, which is Killer 5, launching for you this Saturday at 9 o'clock. Do not forget to check it out and do attend it live. All right, so let's get going with electrostatic force. Are you guys ready? Are you minions ready? Let me know. All right. Oh, acha, you didn't attend 7 a.m. lecture. Oh my God. I was thinking in my mind, you're talking about yesterday's class, but yes, I conducted a class at 7 o'clock in the morning as well. Guys, I really want you to wake up in the morning. I want you guys to cultivate that habit in you. In fact, a lot of channels in Vedantu itself are having their classes at 6 o'clock. do you know there are a lot of YouTube channels in Vedantu which conduct classes at 6 o'clock in the morning? Yes, some are at 7 o'clock, some are at 8 o'clock in the morning. And guys, students show full josh, full energy in these sessions. I really want you guys also to get that habit, because a lot of these students have, by my past experience, I'm telling you, they have gone ahead and cracked the examinations with really, really good marks. So guys, getting up in the morning makes the day feel longer. It also changes the way your brain is wired, and it is definitely good for your health mentally as well as physically. All right, let's get ready. And Bhargav, please don't sleep at 3 o'clock. That is very dangerous for your health in the long run. It might cause a lot of problems to your health. So please do not sleep late. Try to sleep by 11 o'clock, max on very rare occasions 12 o'clock, not more than that. Very good. Yes, a lot of you voted for 7 o'clock. Good to know that. Okay, so when we spoke about charges yesterday, I told you, all right, you have already seen these charges dancing. Like charges repel, opposites will attract. We have seen that, but what is the magnitude of the force? So let's talk about it. So Coulomb did this experiments and he figured out what is the value of the force. So here is again a beautiful simulation out here for all of you. Now look at this. These are two charges, Q1 and Q2. All right. Now Q1 is that blue one, which is negatively charged, -4, and Q2 is +10. So if they are oppositely charged, what will happen? They will attract, and you can see that arrow mark growing actually as they come closer, and as they come more close, their arrow marks, that is the forces between them, increases. So the farther you go, the force decreases. The closer you go, the force increases. Now the force is attractive, and notice one thing, the force by this on this and the force by this on this is the same, 679, 679. Has to be, right? Because remember one thing, Newton's third law. So body 1 applies force on body 2, body 2 applies force on body 1, equal opposite reactions. So that's how it moves. And if I change the charge, if I increase the negative charge, look at that. If I make it more negative, the force increases. If I decrease the charge here or over here, the force also decreases. Now, if I make this charge negative and also this charge negative, you can see the force turns repulsive in nature. And if both of them are made more negative, the force also increases. You make it less negative, then the force will decrease. So that's Coulomb's law for all of you. So let's write it down in the formula wise. This is experimental. So how do you write it? If you have two charges, this is Q1 and this is Q2, and they are separated by a distance of r. So r is the separation. Then the force between them. So what is this? The force, the electrostatic force. All right, this is the electrostatic force of interaction between them. Is given by a constant into charge 1 into charge 2 divided by r square. Now there is no need of putting plus or minus. We are talking about the magnitude of the charge. Direction everybody knows. Like charges opposite, unlike charges attract. So don't worry about the minus plus sign. That will unnecessarily, play with your mind and it will confuse you. A lot of teachers do that, and I'm not going to do that with you because I want to keep things simple for all of you. Hello Mechatronics, welcome all the minions out here. Okay, so now going ahead, what is this K? This K is basically called as the Coulomb's constant. So this is your Coulomb's constant, and the value for that approximately is 9 into 10 to the power 9 SI units. So if everything is in coulombs and this is in meters, then this is 9 into 10 to the power 9. Keep this in mind. Yes, so this is very important. Now you can see as r increases, that is the distance between them increases, the denominator increases. As the denominator increases, this ratio will decrease. That means the force will also decrease. So distance increases, denominator increases, force decreases. Answer this simple question. Where do you think the force will be exactly equal to 0? Answer in the chat box. Where do you think the force will be exactly equal to 0 between the two charges? Guys, come on, answer in the chat box. Oh, by the way, let me also tell you, this can be also written down as 1 upon 4 pi epsilon naught. That's another way of writing this constant. So product of charges, square of the distance. This is Coulomb's constant. This can be written down as 1 by 4 pi epsilon naught. Yes, Anand, we are taking concepts of advanced and mains every day. So we are doing mains level concept and advanced level concept, both every day. Yes. Okay. This epsilon naught is called as permittivity. This is called as permittivity. All right. Permittivity of free space. That's called as the permittivity of free space. You will learn more about permittivity in the classes ahead. For now, just think of it this way. If the medium changes, this value changes, the value of the force also changes. So in vacuum, the permittivity, the force, how much it is permitted in vacuum, it's maximum. But if you change the medium, if you place the charges in water, wood, ceramic, cement, etc., the value of the force will change, because the permittivity, how much will it permit the forces to interact, the charges to interact, that will change. All right, a lot of you are saying infinity for the zero force. Answer is no. At infinity, the force is not equal to 0. The force tends to 0. Understand that. The force tends to 0. There is a difference between tending to 0 and equal to 0. Have you ever seen two people fight on the road and they're like, I'm going to hit you, I'm going to smash your face? Have you seen some kind of fight happening between two people? Maybe on the road, maybe in your class. Yeah. Yes. All right. Very good. Some of you said it. Very good, monkey. Okay. And have you seen? Maar ke to dikha, chhu ke dikha. You touch and show me. Yeah. Oh my God. Munna bhai says every day in the class. Munna bhai fights every day. Yes. Yalini also sees it in the class every day. You touch and show me. Then the other person says, I'm going to touch you. I'm going to touch you. I'm going to slap you. I'm going to punch you. And then they get their fist very close to the face. I'm going to hit you. You're sure, right? You're sure. I'm going to punch you in the face. I'm going to punch you. But they don't actually punch. That is the meaning of tends to. The force tends to 0. That does not mean it becomes actually equal to 0. Understand? It approaches 0. It is not equal to 0 yet. Yeah? Okay. And if you actually punch his face, oh, then you have made it equal to 0. So that's what has happened. Okay. I hope this is clear. And let's proceed ahead. Okay. I hope everybody has understood this meaning. Now let's solve some questions based on this. I hope it is there already in your notes. Okay. A soap bubble is given negative charge. Then, so earlier it was not charged, you give negative charge on it. What do you think this soap bubble will do? Will it decrease its size? Will it increase its size? Will it not do anything? Or nothing can be predicted as information is insufficient. Come on, guys. All right. So Srivardhan, if you want it in unit vector, just put that r hat. I don't see any purpose of it, because half the times, 99.99% of the times, you're going to solve it by vector resolution. You have learned vectors for that. Who is going to write the force equation in vector form? I don't think it's needed apart from boards, that vector form. So in JEE, 99.99999% of the times you're going to solve it by vector resolution, vector formula and all that. So nobody's going to do it by, that r hat form and all that. All right, B for Bombay. All right, a lot of you are saying B for Bombay. Yeh Bombay, yeh Bombay, yeh Bombay, meri jaan. Yeah, Bombay, meri jaan. All right, let's see. The correct answer is actually Bombay. Okay. Yes, and why is it Bombay? B for biryani, B for Bombay, B for boy, B for I don't know what else. Okay. So, guys, why should it increase? All the negative charges on that are going to repel each other. Negative repels. Positive, negative attracts. So all of them are going to repel each other and it's going to grow bigger and bigger until it bursts. Yes, that's how it is going to be. Very good. So yesterday's answer, well, I'm going to post it in the comment section only, nowhere else. So guys, you have to come up with the answer. So guys, keep posting. Every day I'm going to give you a nice question and you have to think, and if you don't get, it's okay, keep trying. And someday somebody will get it and you should keep a track of the comments. All right, that's what you're going to do. Okay, let's get going to the next question coming up on your screen, and here it is. So guys, what we have is basically, you know, two pendulums of charges Q and 4Q, and they are making angles theta and theta, or I don't know, theta 1 and theta 2. Understand, both the pendulums have same mass but different charges. Two pendulums suspended from the same point, same mass but different charges. How will their angles look like? How will the angles look like? Will it be like this, like both of them are equal, or the charge Q at the center, 4Q away, or 4Q at the center, like below vertically, and Q on the left side, or the angles will be different? What do you guys say? Come on, think about it. Ankit, पढ़ के हालत खराब हो गई है. So then what should I say? पढ़ा के मेरी हालत खराब हो गई है? No. In fact, I enjoy teaching. Guys, enjoy learning. Don't treat it like, oh my god, this is for scoring marks, this is for JEE. No, don't think of it like that. D for Dehradun, same mass, I don't know. Okay, some of you are saying A for Andhra Pradesh, D for, guys, please don't choose your favorite cities and mark answers accordingly. Read the question carefully. A for Andhra Pradesh, B for Bombay, C for Chennai, D for Delhi, D for Dehradun, D for Donkey. Come on, guys. Okay, well, the correct answer is actually A. Yes, remember that. Okay, Abhi, Bhabi. Oh, the Bhabi has come. V Enthuse Bhabi is here. Okay, so don't worry, you have just missed few questions and a little bit of theory. Watch the replay later on. So guys, the thing is, please understand, if you have 4Q charge and Q charge, who applies more force on the other? Will Q charge apply more force or will 4Q charge apply more force? Some of you might think, oh, 4Q is big, so it's going to apply more force. Wrong. If you see the formula of the force, it's K, Q1, Q2, product of the charges in the numerator, and downstairs you have R square. So whether you write Q1, Q2 or Q2, Q1, it really doesn't matter. The magnitude is the same. There is no ego between them. Oh, I'm big, I'm going to apply more force on you. Oh, I'm weak, okay, I'm going to apply less force. No, that's not what they're going to say. Newton's third law, guys. Action, reaction. If one applies 10 Newton force on 2, then 2 applies 10 Newton force on 1. That's how it works. So the forces are same, masses are same. What else do you want? The angles will be same. I hope this is clear. Yes. Is that clear? Everybody understood this? Yes, both apply equal forces. Very good. So that's the way to solve. Let's get going to the next question coming up on your screen. Two equal and opposite charges. Two equal and opposite charges are placed at certain distance. There is a force F between them. Two equal and opposite charges are placed at some distance. The force is F. Now, 25% of charge from one of them is taken and transferred to the other. Then what is the new force between them? Come on, think about it. Sakshi, can you do one thing, beta, please? Can you watch the replay again, because I have explained it? Alright, so that way we will not deviate from the topic. So please do that. Okay, let's see. Come on, guys. Some of you are saying B, some of you are saying C. Okay, come on, work it out. B for Bombay, C for Chennai, A for Apple, Andhra Pradesh, Ahmedabad. What is it? D for Delhi, D for Dehradun, C for Chapati. Oh my god, that Chapati song, guys. Oh my god, I heard that pathetic song. Chapati. There is a song called as Chapati. Can you believe that? Somebody actually made that. Yeah, there is a C for Chapati. Yeah, Chapati song on YouTube, and it's worse than Dinchak Puja. Yeah, it's worse. Okay, so let's get going, and yes, and let's see what should be the answer. So first of all, Q, because it's given equal charges but opposite. So this is actually minus Q. So if you want, I'll write it explicitly. This is negative Q, this is plus Q. And there is some distance between them, and the force between them is F, and that value of F is K Q square by R square. Now we do a small change in that. Remember, 25% is 1/4 of the total charge. 25% is basically 1/4 of the total charge. So out of Q, if you take 25%, 75%, which is 3/4 will be remaining. So it will be 3Q by 4. I hope this is clear. So 25%, all right, 25% taken out. All right, it has been taken. 25% has been taken. And where did you put it? On the minus Q charge. So guys, -1 plus 1 by 4. Because 1/4 of the charge has been put over here, and that was a positive one. Do not forget that. That is going to be -3 by 4. I hope this is clear. So hence, this charge will be -3Q by 4. This charge will be -3Q by 4. So guys, what will be the new force? The new force will be K into magnitude wise. Don't worry about the directions and all that. 3Q by 4 into 3Q by 4. Correct? We are talking only about the magnitudes. This is new force divided by R square. 3 3s are 9. 4 4s are 16. So 9 by 16 K Q square by R square. But what is this? This is nothing but F. Remember? So it is 9 by 16 times of F. That's the answer. I hope this is clear. Yes, this is based on charge conservation, which I taught you yesterday. And it is also based on the second concept that charge is a scalar. So you just add or subtract them, taking the values into consideration. So you took 1/4 of the charge and put it here. But this charge was negative, do not forget that. So -1 plus 1/4 is -3 by 4. That's it. Understood? A lot of people would have made the blunder. I know that. Yes, Sonal Rastogi, definitely gravitation will be a piece of cake after studying this chapter, for sure. No problem, Munna bhai, happens. Life में गलती होता है, टेंशन नहीं लेने का. समझा क्या मामू? Okay, let's get going. Okay, let's get going to the next one, and that was 9F by 16. Okay, cool, very good, V Enthuse FC fan club, very good, very good. If two like charges of magnitude 10 to the power minus 19 coulomb and 9 into 10 to the power minus 19 coulomb are separated by a distance, okay, of how much meter? 1 meter. One is +1 into 10 to the power minus 9, and other one is 9 into 10 to the power 9, separated by 1 meter. And you want to find a point where you can place a charge and the net force experienced by the charge is 0. Where will you place the charge between them so that the net force experienced by the charge is 0? These are the 4 options. Let's see which one will be correct. Oh, Ankit, thank you. Yeah, the blunder was worth it. Yes, happens. No problem. I like movies, guys. I love movies. Thank you, Jay. Any class in the morning? So, Vedantu Bhabi, the thing is, the next week, yes, we are going to have classes again in the morning. So I love the morning sessions. I feel so energetic after the 7 o'clock sessions. I'm so active. I mean, I'm not even sleepy, guys. I woke up at 6 o'clock in the morning, and I finished my breakfast before the class, and I'm still all active out here. So yeah, we're going to have 2 sessions next week for sure. Again, 0 to hero. Yeah. So let's see how many of you got it. A, C. My God, don't say A and C, guys. It really hurts me because, AC reminds me of me sweating out here in front of all these lights, producing all the heat. And I have this stupid fan. Which definitely does not help me. Okay, and it's getting really hot in here. Thanks to global warming, or I don't know what. Who should I blame? Okay, so there we go. Let's see. Okay, And a lot of you are saying D. I don't know. Well, let's figure it out. I don't think it is D. I don't think. You cannot get every point. No, I don't think so it is D. So guys, there is +1 over here into 10 to the power minus 9. I'm skipping it. And +9 into 10 to the power minus 9 again over here. The distance between them is 1 meter. Now, if you place a charge somewhere here, let's say at a distance of x, so this distance will be 1 minus x. So you have placed a charge here. Understand this +1 will apply a force in this direction. This +9 will apply a force in this direction. When these two forces will cancel each other, that's when the net force will be 0. So the question is, where should you place it so that the force experienced by this charge is 0? That means the two charges cancel their forces. So what is the force by this charge over here, +1? So it is going to be K into 1 into 10 to the power minus 9, because that's the charge, into Q, because that's the charge here, divided by x square, because the separation between both of them is x. And numerically, magnitude wise, it should be exactly equal to K into 9 into 10 to the power minus 9, correct, into the charge divided by, please keep in mind the distance is 1 minus x whole square. Now a lot of things are going to get cancelled. Let's see what and all. K cut gaya, gone. 10 to the power minus 9, 10 to the power minus 9, gone. Q, gone. So I'm just left with few of the things. How about taking this dude over here? So it's going to become 1 minus x whole square. How about taking x square over there? Remember, 9 is still remaining. So 9 multiplied by x square. Is that clear? Thank you, Abhibabi. Glad you're loving all that. No, you don't need to use minima, maxima concept. Very good, Taraneshwar. And just take the root of it. So it will be 1 minus x is equal to 3x. Therefore, 1 is equal to 4x. Therefore, x is equal to 1 by 4, which is 0.25 meters. This is what I'm going to get. X is 0.25 meters. So 0.25 meters from +1 charge. That means 0.75 meters from the other charge. Hence, both of them are correct. Hence, the correct option is Chennai. I hope this is clear. Is that understood, minions? Is that understood? Very good. Excellente. Very good. Let's get going to the next question coming up on your screen again. Get ready. Very good. A lot of you getting +4. And there we go. Both A and B are correct. We Enthuse FC South India fan club. Try to watch as much as possible live. Okay? So you need the knowledge of forces, FBD, vectors. You need obviously good maths to solve all of this, because this is 12th standard syllabus. So it's okay. You might not understand maybe 50% of what I'm teaching. It's okay. Happens. That's how life is. You can watch it again, but try to watch it live, because that's when you'll get the mood. If you watch it recorded, I'm not sure how much mood will be there. It's okay. Yes. All right. Global warming caused by you guys. Okay. So next question, guys. Let's see how you can do this. 4 charges are kept. Where are the charges kept? Here. +q, -q, -2q, +2q. At the corners of a square ABCD. Now, what will be the force on a positive charge placed at the center? If you take a positive charge and put it at the center, because of these 4 charges, the force on that central charge will be along which direction? Come on, think about it. Okay. Very good, Swati. Okay. Okay, Mohammad, Irfan. Okay, come on, let's see how many of you can do this. Come on, minions, you should be able to do this. D, A. Come on, do vector. Think about vectors, draw those lines, see where the forces are approximately, you'll get an idea. Come on, minions, you can do that. It's not so difficult. B, D. All right. A lot of you are getting confused. Okay. This is beautiful question. I'll tell you. This is beautiful question. It's not so difficult also. So what you need to do is think about what will be the direction of the forces because of each charge. Now because of plus q charge, so I'm talking about the center over here, because of the plus q charge, what will happen? A force will be directed away along the diagonal like this. I hope this is clear. Because of the plus q charge, there will be a repulsive force. Okay, let's say I call it F for example. Now by symmetry, think about it, this negative charge will also pull, not push, it will pull, it's attractive, by the same force F. Do you guys understand why the force's magnitude will be same? Because this is also Q, this is also Q magnitude wise. Direction wise, yes, this Q is pushing, that negative Q is pulling that charge. Now, the other things that you need to account for is, think about this. Okay, so this plus 2Q, what will this plus 2Q do? This plus 2Q will push it away, but since the charge is double, the force will also be double. I hope you see that. The charge is double, so the force will also be double. Remember, force is proportional to the product of the charges, correct? Great. And then this negative 2Q will pull, but since the magnitude is twice, so the force will be 2F. I hope you saw that. Yes, I hope you saw that, correct? So what will happen now? Guys, cancel some of the forces. First of all, this F and that 2F will partially cancel and you will get only F over here. I hope this is clear. 2F here and F there will cancel and only one F will remain. Similarly, 2F here and that F there will cancel and you will have only one of the F's over here. Is that clear? I hope this is clear. Yes. So understand, they won't exactly cancel out each other because they are unequal in magnitude. 2F is larger, F is smaller, so the remainder of the forces is F. 2F is larger, F is smaller, remainder is again F. So two of the F's are remaining over here. Now what will be the resultant of both of them? The resultant of both of them, this will be like this. This is the resultant force. Now guys, can you see the resultant is in the horizontal direction? So it is definitely option D, which is perpendicular to the side AB. You can see that it's perpendicular. You can see it's perpendicular to the side AB. Is that now clear? Understood? I hope I have explained it well, and I hope if you have still some doubts remaining, you can definitely watch the replay again to understand whichever point you did not understand. Best book for 12th board, NCERT and the refresher. That's it. Okay. No problem, Anand. I mean, as we become a bigger and bigger family, you know, a lot of students will enter. So don't worry about it. And Anand, there is always an option to join the Vedantu subscription where you won't have any kind of spamming out there because the chats are controlled and the chats are handled by teachers. There are 5, 6, 7 teachers apart from the main teacher who are just meant to answer the students' doubt. So students don't answer students' doubt in the regular classes pro subscription. In fact, there are dedicated class teachers to just solve your doubts in the class, and the teacher is teaching. And certain times, obviously, yes, we open the chats also, and you can also interact with other students. All right, refresher. Just Google it, Ankit. You will understand it. All right, later on, you just Google it. Okay, cool. Let's get going to the next question. Now, let's talk about what is field. Oh my God, you are just adding all the charges. Oh my God, boom, that's not the way. Okay, cool. No, it is not neutral, Mohammed. Captain, why is the force pulled by A, 2F and not 4F? Monkey, the thing is, or Krito, the thing is, remember if the charge doubles, then the force will double. Both charges are not doubling. See, Q1 and Q2. If Q1 doubles, force will double. Q1 and Q2 both double, the force will become 4 times. So the central charge was the same, just that the charges on the corners were different. One was Q, so force was F. The other was 2Q, so force was 2F. I hope this is clear. Okay? Yes. Okay. If it was neutral, then there will be no force, right? Obviously. Okay. Let's get going to the next one. Yes. Oh my God, so my hairstyle is different every day in these days. I don't know, guys, that holy party, after that my hairstyle, I'm never getting my original hairstyle back. I don't know what happened after that holy party. My hair is all messy and I like it in a way. Okay, so now let's talk about what is field. Now, many students, trust me, don't know what is field. Even if you have studied it in your coaching, I doubt if you have been explained this way or if you know the true meaning of field. So let's see what it is. Now, say for example, all right, let's get going, guys. Here I had a holy party last weekend, by the way. Okay, let's say there are some charges. This is nothing but a system of charges. Okay, so I don't know, there could be plus, minus, plus, 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 plus. Some charges are there, and at some distance, okay, at some distance from that system of charges, you think about a point, just an imaginary point. Nothing actually is there. This is some empty space. That's it. Now, imagine if I ask you, if there is nothing at that point, will these charges attract or repel this point? Will they attract or repel, or will they do nothing? Come on, answer this question, guys. Come on, think about it. Think about it. Moment, like I said, if it was neutral, then no force will be there. Will these set of charges, will they attract or repel this point? Come on. Or will they not do anything? Jaideep, Ramesh, I'm very good. Guys, they should not do anything because there is nothing over there. It's just an empty point. Charge can repel or attract a charge. It cannot do anything to nothing. I hope you guys got it. A charge can only push or pull a charge. If there is nothing over there, what can it do? Nothing, right? Okay, correct. Now I do a magic and mysteriously I get a charge and place it over here, and I call it Q. I get a charge and place it here. Okay, suddenly, zoop. My question to you is, will this charge experience force? Will this charge experience force? Think about it. Yes or no? Repulsive or attractive? I'm not at all bothered. It's okay. I don't care. But will it experience force is my question. And if your answer is yes, very good. It will experience force. My question to you is, before this charge was placed, there was nothing over here. There was no force. Suddenly when you place this charge, how the hell did this charge know that, oh, there are so many charges here and I should be pulled or pushed with this much force? How did this charge get to know that if I am here, oh, then my force will be different and in this direction and of so much magnitude? How does a charge which is placed around other charge get to know how much force it needs to feel? That's the problem. I hope you guys get that dilemma. I hope you guys get that concept. That means even before placing that charge, understand there is something in that nothing. There is something in that nothing, and that something is that piece of information for this charge that, hey, you are going to experience this much force if you come here. Hey, you are going to experience this much force if you stand here. So that piece of information which is around any charge is called as field. I hope this is clear. So field is in a way piece of information or pieces of information around a charge which tells you how strong or intense, in what direction will the force be experienced if you place a charge. I hope this is clear. Yes, deep quotes out there. There is something inside that nothing, and that something is that information, and that information is the field. Keep this in mind. Munnabai, if you write this definition in the board examinations, your teacher is going to go mad. Your teacher is going to be like, are you insane or what? Have you watched 3 Idiots scene where Amir Khan is trying to explain machine and definition of machine and all that? Yeah, it will probably something like that. All right, Neha thanks me for the information. All right, okay. Yeah, it will be something like that. If you watch Three Idiots, you will know what I'm talking about. Okay, so now how do I define field in mathematical terms? So here is the thing. Field is there even when this charge is not there. Please keep this in mind. Yeah, remember there is always that something in that nothing. So at that point that field is there. Field is defined as the force divided by test charge. Now the test charge is assumed always to be positive, test charge, but not any test charge. You cannot take 100 Coulomb positive charge and be like, oh, what is the force on the 100 Coulomb charge, and force divided by that charge will give me field. No, do not do that. That's not how field is defined. This test charge should be infinitely small. Why should it be infinitely small? The reason why it should be infinitely small is because it is a test charge. You are testing it. Imagine, guys, do you guys have a bully, like a very mean bully person in your class? Very big one. He always hits, he punches you on the face, he throws your bag, he throws water on you, he steals your tiffin box, he drinks your water bottle. Yeah, drinks water from a water bottle or something like that. Yeah, do you guys have a bully? So think of these charges like a bully, that big, fat, that very mean guy in your class. Now, he has his own field. Think of it like, that bully guy has his own field. It's like his area. Hey, you come in this area, I'm going to smack you, I'm going to hit you, I'm going to punch you on the face. Now, there is a field in that. Now, how do you know there is a field? How do you know he has his presence? How do you know he has his field in that area? So you send something to be tested, but you don't want to anger him. You don't want him to get angry and run behind you. You're just going to test. You're going to be like, you're just going to touch him and be like, and then he looks at you and you get scared and you'll be like, oh my God, he is scary. I'm not going to mess around with him, and you're going to run away. So you place a teeny mini charge out there just to test. You don't want to make this guy angry. You don't want him to get disturbed. If you place a big charge, these charges might move here and there and you won't like it. You won't like it. So that's why you use an infinitely small charge. I hope this is clear. Is this understood? Yeah. Neha is going to punch him back. Very good, Neha. You are a bully. Yes, very good. Okay, more to woman power. All right. As he finds, yes, you are a little bit late by 40 minutes. For boards, Ankit, I'll respond to your queries in the chat box later on. Okay. Okay. Now, the way I write it is something like this. So if you have charges, all right, if you have charges, doesn't matter, and if you are at some distance and if you are at some point. So finally, what is our definition, guys? The definition is like this. Come on, pay attention. Field symbol is E. Keep this in mind. What is the symbol for field? E. E is force by Q. What is this Q? It's the test charge. It's the test charge. What is this F? Is the force. Keep this in mind. But I'll put limit Q tends to 0 because I want it to be infinitely small. So that is the formula which you should keep in mind. Now, if I ask you what is the unit, isn't it obvious? The unit will be, force is Newton, charge is Coulomb, so Newton per Coulomb. That's the SI unit of field. That's number 2. Last thing, is it a vector or a scalar? Well, it's a vector quantity. Now, if it is a vector, you will be like, so what's the direction? It's very simple. This direction is same as that of the force. So, force and field have the same direction. Keep this in mind. Force and field have the same direction. That means, for example, if I take a positive charge and if I am some distance away from it at this particular point, guys, can you think and tell me, will the field be in direction 1 or direction number 2 because of this positive charge? Will it be in this direction 1 or direction number 2 because of this positive charge over here? Will it be in direction 1 or direction 2? Think about it. Think. Guys, place a test charge, place a sample. If you place a sample positive charge, remember the test charge always has to be positive by convention. If you place a positive charge, which direction will be the force? Obviously here. So where is the field? Obviously here in direction 1. But if you replace this positive charge with a negative charge, then what will be the direction of the field at this point? Think, take a test charge. This is our test charge. What direction will it experience force? In this direction, direction number 2. So the field is in this direction, as simple as that. So field acts in the direction of the force on a positive test charge. Keep this in mind. Okay, a lot of things that you have learned. So electric field of a charged particle, this is something what you can write in your boards, is the field surrounding the charged particle in which it can exert an influence on another charged particle. So this is what it looks like. This charge can apply its influence, it can influence other charges in its vicinity, and you can see that as you move away, its influence, its field reduces. I hope this is clear. Okay, cool. Shall we go ahead? This is something what you can write in your books, in your boards maybe. Okay, very good, monkey. All right, great. Let's get going to the next one. Okay, now let's do some problems, but before the problem, the first theory derivation, field due to a charge, a point charge. You have a charge Q. At this point, I want to know what is the field. Abhi Bhabi, I don't know Telugu. No. Okay. So, coming to this, guys, let's say this distance is R. I want to know what is the field here. What am I going to do? Place a test charge. And what is my test charge going to be? Small q. So, my field by definition is limit force on the test charge by q. Q tends to 0. Now, what is the force? What is the force between any two charges? What is the force by Coulomb's law? K, Q, Q divided by R square. So that's the value of F. But there is one small q also over here. There is one small q also here. So what will happen? That q and this q will get cancelled. And none of these terms here have small q here. If they don't have small q, guys, there is nothing to take limit of. For taking limit, there should be something inside. So the answer will be KQ by R square. That's the field, and this is the formula which you should remember. Keep this in mind. Very good. And if you want, put K as 1 upon 4 pi epsilon naught. That's also valid. So due to a charge, it is KQ by R square. No QQ. It's just Q. Okay? Yes. Okay. Now, also keep this in mind that you need to know the graphs of the field. Alright, so if this is field and this is distance, how will the distance and field graph look like? I think that's not difficult to visualize because R is below, downstairs. So if R becomes large, this ratio reduces. And if R becomes small, the ratio increases. So the graph is going to look something like this. If R becomes large, the field reduces. If R becomes small, the field increases. No, it's not a parabola. It's just a curve. It's not a parabola, guys. It's just some random curve. It's just a curved line. That's it. It's just a curve. That's it. Okay, that's what you should keep in mind. All right. And by the way, Rudresh, I'll answer to all your questions. Just ping me on my Instagram handle or post a comment after the video ends. Definitely, I try to answer all your doubts and queries, whichever you post in the comment section after the video. Okay, great. So Neelam, same thing. Please post all your comments in the comment section below after the video is over. So keep all these things in mind. Let's move to some problems. And remember, guys, you know, all those of you who want to get enrolled into a regular batch at Vedantu, because the situation out there is now very bad. I'm pretty sure even if you join an offline coaching institute now, it's not going to be offline for most of the months. And you know, the situation is very bad out there right now because of the virus spreading very fast. So guys, the best online experience without using Google Meet, without using Zoom, we have a separate platform called as Wave, where you know you have class teachers to solve your doubts within the class. You get test series, you get other courses like for KVPY, for Olympiads, for boards, all under one roof. That is very important, because when you join a coaching, you do not get all these things. You get either this or that. And if you get all of that, then you have to shell out a lot of money. And then how about the books? Well, we give you the Tattva material, which is the hard copy. And guys, you have the additional benefit of joining thousands of micro courses by any teacher that you want. Lots of micro courses to help you boost concepts in special topics or all the micro chapters which are there in JEE or NEET syllabus. And the last thing but not the least, option for studying in English as well as Hindi, which I'm pretty sure not many coaching institutes offer. So the price is 43,739 after 10% discount, and you can join using the coupon code SSHPRO. The link for and the details of all the courses is there in the description box below. Please do not forget to check it out. Let's start solving this question out here. 4 charges are arranged as shown at the corners of a square. The direction of the field at the center of the square is, come on, think about it. Hello Yashu, welcome. Jaya, I'll tell you one thing. If you don't want to pay 43k, there is one simple option, Jaya. When you go to the payment page, there is an option of easy EMI. So what you can do is, you don't have to shell 43k in one go. Every month you pay 3,000, 2,000, 4,000, that kind of installments. And there are a lot of financing options available. So every month you pay few thousand rupees, and that's how you can pay all the installments. So I feel you can do that. Okay, so yeah, I hope that helps. Okay, a lot of you are saying A, some of you are saying D. Come on, think about it. Come on guys. D for Luffy. Okay, well, let's see this. Guys, this question is somewhat similar to the question which we just solved some time back. Welcome Arun Dev. This is the second class of Electrostatics. This is a long-term batch, JEE 2022 batch, and this is the Pathfinder series. Welcome, and do not forget to hit the subscribe button if you are new to this channel. And guys, if you are already subscribed, please show us your love and support by smashing the like button down there. Now the question is, there are these charges, and the question is, what is the field's direction? Okay, now think about it. This Q will create a field in this direction, correct? It will push it away like this. Positive charges, the field is away. This 2Q will create a field in this direction. This 3Q will create a field in this direction, correct? And this 4Q will create a field in this direction. But all their magnitudes are not same, and they are not going to cancel out each other. Be careful. In fact, if I'll write the magnitudes, let's say it is 1 unit because the charge is Q. This 2Q charge will create a field of 2 units. This 3Q will create a field of 3 units. That 4Q will create a field of 4 units. Guys, now 3 is here, 1 is there. So effectively, how much is remaining? 2 is remaining. 3 is here, 1 is there, opposite. So how much is remaining? 2 is remaining. 3 minus 1 is 2. 4 is here, 2 is there. So obviously how much is remaining? 2 is remaining, again in this particular direction. Now this 2 and this 2 together will give the net field in this direction, which is downwards, which is along DC. All right, this line. Also along this line, that's what you're going to get the net field. Very good, very good. I hope this is clear and everybody has understood this. Beautiful question out there. Now, are you guys interested to solve a slightly tricky problem? Let's do that. Yeah, it's not so simple. So let's see how many of you can do this. It's kind of advanced kind of questions only. This is very, very interesting. Oh my God, Chetra Reddy, you are silent for like the whole session. It's good. As long as you are understanding and you're making notes or something like that, it's okay. At least if you write once or twice, hello, hi, I will know that, okay, Chetra was here, okay, Priyanka was here, okay, Neelam was here, okay, Jaya was here, Yalini was here, Avinash was here, all right, Arun is here, Usha is here, Kiruto is here. So yeah, keep typing in between so that I know you guys are here. All right, cool. Very good, Chaitya Reddy. Hello, Usha. All right, so guys, think about this. There are 4 charges on a square. This is X, Y plane. Think about a point here, outside the plane, somewhere here. What is the component of the field in this Z direction? What is the component of the field in the Z direction? Think about it. Because of all the charges. Very, very interesting question. Let's see how many of you are going to get it. Very beautiful question. You need to visualize this. Unless you visualize this, you are not going to get it, guys. Let me tell you that. Come on, minions. Come on, come on, come on, come on, come on. Let's see how many of you can do this. Very, very interesting question. Come on, minions. Let's do this. Okay, if you get it, you will get it within 10 seconds. Else you will keep on struggling with it. Okay. Chalo, let's first of all visualize what has happened. So first of all, let me draw in 3 dimension this particular diagram. Okay, like this, and you have like this, okay. Oops, very difficult to make one. I will try. Okay, 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 this. Oops, my goodness, so crazy to draw this diagram, but I will try. Okay, so think of the charges, all right, Q, Q, minus Q, minus Q at the base of an Egyptian square pyramid. At the base of an Egyptian square pyramid. Now think, what will the 2 positive charges do? The 2 positive charges at this particular point, because think when you are here, if I draw these lines, it becomes like a square pyramid. Think about it. It becomes like a square pyramid as if you are looking at it from the top. Think about it, all right? It's as if you are looking at it from the top. So these 2 charges will apply a field in this direction and yeah, along this direction like this. This will be the direction of fields. Now think about it. Yes, 11 to 12. Yes, think tanker. This is for 11 to 12 standard students. Because of the negative charges, the field will be in this direction and this direction. Try to visualize this. I mean, I will need 4 pens for that. 2 of the fields, all right, because of the 2 charges below will be in this direction and that direction, and 2 of the other fields will be in these 2 directions. One there and one here. Think about it. It will be like this. This is XY plane. The pyramid's vertex is here. So the 2 charges here will apply fields like this, and the 2 negative charges will pull and they will apply fields like this. So the resultant, think about it, the resultant, will it not be in this direction? So one vector there, one vector here, one vector here, another vector here. So the resultant of all of them, just think about it, guys. The resultant of all of them, how is it going to be? It's going to be like this. It's going to be horizontal. Isn't that clear? Isn't it clear? It will be horizontal. So if it is horizontal, will there be any component in this direction? Will there be any component in this direction? Because these 2 charges will apply the field like that. These 2 negative charges are going to pull it. So this one negative is going to pull it there, and that negative is going to pull it there. The field will be in this direction. There is no component here. So the component is 0, guys. Yep, the component is 0. Hence the answer is 0. There is no need of other options. That's it. The answer is 0. Very good. Yes, I hope this is clear. Okay. So today's talk, try not to use a smartphone. Try to use a simple phone without WhatsApp, or try to put restrictions on your smartphone. That's what I would say. Shreyas Hebbare, Wasim sir is doing little bit better. He's slowly healing. He's out of the hospital. All right. So I'm hoping that he'll be there soon. Okay. Now let me talk about this, where you have a ring, and you want to find the field because of that. You have a ring and you want to find the field because of that. So let's try to do this kind of a problem. So just imagine, guys, all right. So you have, okay, a ring like this, okay, a ring like this, and on the axis you are here and you want to find if this ring has charges on it, what is the direction and magnitude of the field. If this ring has charges and you are on the axis of the ring, what is the field magnitude and direction. Okay, so let's try and do this particular problem. Let's try and do this, guys. Okay, so first of all, let me show a ring somewhat like this. This is a ring and this has some charge over it. Right, this ring has some charge over it, something like this. And then you are thinking about an axis of the ring, which is something like this. This is the axis of the ring. And I want to find, if it's given to me, the radius of the ring, alright, the radius of the ring is r, and I am at a distance x from the center of the ring, what is the field over here? That's my question. Okay, let's try and do this. Are you able to visualize this diagram? So this is a ring, 3-dimension, visualize it. So that ring is actually like this. I wish I could show something more, but think of my studio light out here. Okay, I hope you can see this. This is my studio light, ring light. So this is a ring and you are on the axis of this ring and you want to find the field over here. So guys, think about it. All these charges out here. Okay, this light is too bright for now. Let's just use the back of this. So guys, just think about it. All these charges, let's say I take a charge here, it's going to apply a field in this direction. A charge here will apply a field in this direction, correct? A charge here will apply a field in that direction, correct? A charge here will apply a field in that direction. A charge here will apply a field in this direction. And a charge there will apply a field in this direction. So I hope you see that all the charges on this ring will apply fields in all the directions like this. All the directions like this. I hope this is clear. All the directions like this. Isn't it clear, guys? So think about it, guys. Oops, let me put it back. I need some lighting. Okay, so now you know why I sweat a lot, because all these lights, this is just one of the lights. There are more 5 lights or 6 lights apart from this. Okay, so guys, the thing is, so what you need to worry about now is this. Each of those charges will apply field in all these directions like this, but the component that will matter to us will be only the horizontal component, not the vertical component. Why? Why this component, the perpendicular component, will not matter, only the parallel component will matter of this electric field. So electric field due to a charge, let's say dq, all right, will be dE. That dE will have 2 components like this. Only this component is going to matter. I hope this is clear. Yeah, because these components are going to cancel out. Think, because of this dq charge, the field is here. Because of some other dq charge, the field will be there. That field will also have 2 components. And now you can see this component and this component cancel each other. The perpendicular components cancel each other. Only these components will add. Is that now clear? Is that now clear? Similarly, this charge, all right, all these components will cancel, only these components will add. So now just let me draw a dotted line. Let me take this as theta. So this angle is also theta. So DE parallel will be DE cos theta. Think about it. It will be DE cos theta. Clear? So the net field will be the summation. Summation means integration. The other word for summation is integration of all the fields in this direction. So all the fields in this direction will add. I'll repeat again. Remember, if this is the dotted line, the field due to this charge on the top is down like this. The one here is like this. So all the fields are in these directions. So each field D due to each charge dq will have 2 components. Each field will have 2 components, one like this and one perpendicular. The one which is like this will add, the one which is like this will keep on cancelling out, because every field will have some component in this plane. Now the net field will be the sum of all these fields which will be integral of dE. That means it is integral of dE cos theta, which means, oh, what is dE? The field due to dq. What is the field due to a point charge? What is the field due to a point charge? It is k. Charge is dq divided by this distance. How much is this distance? That distance is root of r square plus x square whole square. Correct? That distance using Pythagoras, remember, this distance is r square plus x square and the whole square of that. Very good. And that cos theta is, look at that, cos theta is x adjacent divided by hypotenuse, which is root of r square plus x square. All right, root of r square plus x square. That's it. Yeah. So just do the math now. Now take everything outside. So k is outside, x is outside, and this is going to be r square plus x square whole raised to 3 by 2 integral dq. Just do that. Okay, just this term was missing, so I just put it over here. Remember, this will become r square plus x square whole raised to 3 by 2, and that's it. You're going to get this as kqx divided by r square plus x square whole raised to 3 by 2. That's the answer. Okay, cool. Yeah, I hope this is clear. Thank you, Anjali Kumari. Okay, so this is what you need to do. If you want, I'll just save this up just so that you can, yeah, I'll just save this out here. Okay, cool. Great. Now going ahead to the next and the last part of today's lecture. Yes, derivation is very important, Sonal, very important, very important. Please keep this in mind. Okay, now relation between field and force, very important. Remember, field was force by charge, so force will be field multiplied by charge, as simple as that. So if you have some field, all right, this is some field, and you place a charge over here q, then that charge will experience some force. Now that force is given by the charge multiplied by the field. So the force experienced by a charge in somebody else's field is given by this formula. This is, oops, sorry, not q, over here. Yeah, that is the formula. Keep this in mind. Okay, I hope this is clear. No, Sakshi, derivation is important for boards as well as JEE Advanced. Now, a lot of people, I know many coaching institutes do not do derivations. Guys, let me tell you, every year JEE Advanced is known to ask many questions based on derivations. They've changed the derivations and they ask questions based on that. So JEE Advanced as well as boards, derivations is very important. Okay, cool. I hope this is clear. Great. Is this a continuation of gravitation? No, Subhash, this is an independent chapter, but I have not taught gravitation separately in the Pathfinder series because it's a part of 11th standard. So I'll be teaching it when the 11th standard batch starts. But in my flash series, I have extensively taught gravitation and electrostatics together. So you can watch flash series if you want to study both of them together. All right, cool. Let's get going. I hope this formula is noted down. Last question for today, guys. And that's it. Last question for today. What will be the direction of the force and torque acting on two charge system? What will be the direction of force and the direction of the torque acting on these two charge system? There is a plus 2q charge and negative q charge placed in somebody else's field. Come on, think about it. Oh my god, very good, Anand. If you watch flash series, this will be like very easy and you will learn a lot, because flash was still concise but not very concise also. It was little extensive. It was not like one shot or crash. So that's how it was. Okay, come on minions. So let's see how many of you can do that. Come on minions. Come on. Very good, Venkata Krishna. So Venkata Krishna, that was flash series. The questions are completely different, let me tell you that. And these are extensive series. Okay, what is the direction of force and what is the direction of torque? Come on, think about it. For the 2q charge, the force will be in the direction of the field. Remember, I just gave you the formula, F is Q into E. So if the positive charge is placed, if Q is positive, understand the force is parallel to the field. So if Q is positive, the force is parallel to the field, understand. But if Q is negative, then force is anti-parallel to the field. This is very, very important. So this negative charge will experience a force in this direction. I hope this is clear. Is this understood? Is this understood? The force on 2Q charge will be here, force on Q charge, negative Q charge will be here. Now do you see that these two forces are somewhat like this and they are going to create a torque? Do you see they are going to create a torque? Do you see that? It's going to create a torque. And what kind of torque is that? It's going like this. That's clockwise. So it's going to create a clockwise torque. That's what the answer is. Okay, I hope this is clear. Is this understood, guys? Jugal, I'll always work hard for you as long as I have your love, support, your attendance, your dedication, your faith. Trust me, I'm going to work really hard for all of you. Sir, but it's a single system. Why not just add the charges? Well, monkey, the charges are not at the same point. If they were at the same point, then all the forces will pass through the same point and there will be no torque. But since the charges are separated, you need to take into account that separation. Okay? Yes. Is it important to learn the derivation by integration method? Tarun, if you want to be a top ranker, top 500 ranks, top 1000 ranks, yes. If your aim is 1000 and above, somewhere between 1000 and 10,000, then no. Okay? So that's a clear-cut answer. How many lectures this chapter has? This has 5 to 6 lectures. And there is also a Menti quiz at the end of it. I'm going to cover this chapter in detail, not just this chapter, guys, all the chapters I'm going to cover in detail. Now this is a two-thing question whose answers you're going to put it up in the comment box. Can the field due to two charges separated by some distance be zero? If there are two charges and they are separated by some distance, somewhere around it, it could be positive, positive, negative, negative, positive, negative, I don't know. What do you think the answer will be? Does it depend on what those charges are? How much those charges are? Does the sign of the charges matter? Think about it. All right? Okay, cool. So that's something which you should put up the answer in the comment section below. And all those students who are preparing for the 2021 examination, that's the JEE Mains 2021 or JEE Advanced 2021 or BITSAT or NEET, guys, understand there's a lot of syllabus to be covered in the next few weeks, plus boards is there. So if you feel that you have that pressure and you don't have that ability to cover up all the syllabus, or you're not satisfied with your coaching for some XYZ reason, guys, I would request you to give our Vedantu approach a try, where we'll give you 45 live classes along with the replays, also with assignments, handwritten notes, entire 11th and 12th standard syllabus complete. Also, you're going to get teachers like me, along with test series, along with doubts in the class, outside the class. Test series, you will have 20 tests along with the discussions. And what more you want, guys? I mean, come on. Yeah, all of this at 10,000 now. All of this at 6,000 rupees. And when you use the coupon code SHCC. So please give it a try. Yeah, please give it a try if you feel not so satisfied or happy with your current coaching right now. So do that, and I would be really happy to see you in the crash course. And the entire PDF of today's session will be uploaded in the Telegram group. So if you are not a part of the Telegram group, please join it today by hitting the link in the description box below. And please, yes, show us your love and support. Thank you, Akansha, for all that requests. Thank you. Bye-bye, Neha. Bye-bye, Jatin. Bye-bye, Priyanka. Bye-bye, Keshav. Bye-bye, Santosh, Yalni, Monkey D, Lafi, Shreyas, Yashu. Take care. No, not yet, Yashu. I'll be doing it soon. Don't worry. Okay. Take care. Have fun. See you tomorrow in a special session with me and Abhishek sir. And a special surprise awaits you tomorrow during the daytime. So keep a watch on YouTube, on our channel. And tomorrow night, 9 o'clock, special session with your very own KR Abhishek sir. Yeah, some of you who are from 9th and 10th on YouTube, you know who is Abhishek sir for sure. So take care guys, tomorrow is going to be really amazing. See you all, have fun, take care, stay safe, stay at home, eat well, study well, work hard, dream big.